So there's some examples of the software processes that are described in the book. And you again get the question, which is the best one to use? And you can guess what my answer is going to be. It depends. It depends on the situation you're facing. If you take those examples we discussed earlier, a nuclear power station control software may not be the best way to use an iterative approach to it, to keep releasing new bits each time and new sequential new pieces one after the other. Maybe the sequential approach would be better, to get the requirements fully grounded, develop it all, release it so it's completely working rather than just partially working. So you need to match any process recommendations that you make, and you'll be asked to do that in some of the TMAs, to the case study, the situation you're facing. And you're probably doing this in your real work as well if you work in this area. And again, consider combining processes. You may want to have an iterative approach for core functionality. You may use an open source approach to some of the components. You may want to use some of the agile mechanisms for example, user interface design or reporting. So you could consider combining approaches for different aspects of the software. And the final section, the fourth section of part 2, is about software maintenance and evolution. So in a house context, that's when you reach for the hammer, or maybe you reach for the paintbrush, but anyway, you're starting off with something you've got. How do you maintain and update it, make it more suitable for a current purpose than when it was originally implemented? In the software world, a huge percentage of the overall cost of software throughout its full life cycle is actually spent on maintenance and evolution. In the course materials you read about layman's laws, and this software that's using real-world computer applications has continuous modifications, being updated, being changed, being enhanced, being tweaked to fit this, that or the other, maybe fundamentally changed to meet new requirements from legislative programs or customers, or requirements from internal users, whatever. And this typically it's somewhere between 70 to 90% of the overall cost of software is in the maintenance and evolution stage. So need to consider how we manage this, and to think about this layman's laws, the law of continuing change. So a system that's being used undergoes continuing change. Most of us have seen that in most of the things that we use. But then the law of increasing complexity. A program that's being changed becomes less and less well structured. The changes increase the entropy and the complexity of the program. And that, over time, as a program gets updated, changed, modified, unless you do some work to restructure it, refactor it, to clean it out, a bit of housekeeping, to tidy the dust off the shelves and make sure things are actually clean again, it gets more and more difficult to keep adding on and modifying a program. So there's a simulation you'll be using during the course materials which lets you look at this and play with some of the variables that are involved. And you can do things like set 100% of your effort just for new functionality. And you can see after a while the program becomes more complex, more difficult to release functionality, and your rate of release slows down significantly. On the other hand, if you allocate some of your resources to this tidying up, the refactoring, in the simulation, it's known as anti-regressive work, then overall you get higher productivity if you spend some of your effort doing this tidying up work as you go along. Okay, so that's the final area of the course, maintenance and evolution of software. A couple of comments about TMA2, and you may guess this from some of my comments earlier on. You're going to be asked to show that you understand some of these methods of acquiring software, some of the fundamental activities and processes involved, some of the alternative processes, and some of the issues around maintenance and evolution. You'll be asked to make some recommendations. All the way through, you need to relate your answers back to the case studies. There's no one right answer, but there are typically several wrong answers. If all you do is regurgitate, the 5 different ways of getting software, or 7, or however many there are, I can't remember now, you're not going to get best marks. You have to relate it to the case study. For this company looking for this sort of software, then this is probably a good option because of so and so. This is probably not a good option because of something. And again, consider combining. It would be good to think about this one plus that one, or this mechanism plus some modifications, whatever. Okay, that's it for this little update. Thanks very much for your time. Welcome any feedback of whether this is useful, whether you've learned anything, what was new, what was different, how it enhanced the course materials or contradicted them, or should I do it again or not do it again, whatever. So let me know through my OU email or the first class forum for the course. Thank you.
Naughty boys in nasty schools.